Hi, my name is Shahroz Ahmed, and in this video we are going to discuss a topic of linear algebra. And the topic that we are going to discuss is vector space, or we can call it linear space. So vector space is basically, I'll write it here, vector space is a collection of vectors that can be represented as V and two operators such as addition and multiplication, such that they hold the following properties. So for a vector space to exist, first of all, it's a collection of different vectors, and those vectors should be added with each other, they should be multiplied with each other, and they should also follow the following properties. Then we will call it as a vector space. So the properties that they have to follow are, I'll write it here, such that they follow the following properties, or just following. So let's suppose we have the vectors u, v and w. They belong to the vector space, and c and d, they are the constants, they belong to the real numbers. Now I'm going to write down the properties. So the first property is that if you add the two vectors, they should belong to the vector space. The second property is, if you add the two vectors, like if it's u plus v, like u plus v should be equal to v plus u. The third property is, this is basically the commutative property. The third one is the associative property. So it's like u plus v plus w should be equal to u plus w plus v. U plus v plus w. All right. The fourth property is it says that 0 belong to the vector space. If there is a null vector or zero vector, it belongs to the vector space. So if we add the 0 into any vector, we will get the same vector. So if any vector is equal to 0, it means it belongs to the vector space. The fifth one is, for all the vector belong to the vector space, so that if you add the vector by its inverse, you should get null vector. So this is, you can say, it's an additive inverse property. Now the next one, if we multiply a constant with a vector, we will get the vector within the vector space. The seventh property, if we multiply a constant with the sum of the two vectors, that constant will be multiplied with each vector. So it's like c times u plus v will become equal to cu plus cv. Similarly, if let me just erase it over here. So I'll write the eighth property over here. So it's c plus d of u will be equal to cu plus du. The ninth property is, if a constant multiplies with a vector that is already being multiplied with a constant, so we can write it as c times d of u, where u is the vector and c and d are the constants. I'll put an underline in the vector. All right. So the 10th property is, if we multiply 1 with a vector, we will get the same vector. This is basically the multiplicative identity. Okay, so these are the 10 properties that a vector space should if the vectors follow these 10 properties, then we can say that those vector belongs to a vector space. Now let's see some of the questions related to the vector space. All right, so now the question is a vector space V that is described by the vectors x, y, like by the two variables where x is greater than 0 and y is greater than 0, whether it's a vector space or not. So first of all, we have to identify our region that has been explained by this expression. So here is my y-axis, here is my x-axis. So the region that has been explained, it's greater than, like it's x greater than equal to 0 and y greater than equal to 0. So that region is over here. This is the region where y is greater than equal to 0 and x is greater than equal to 0. So we have to see whether this space can be described as the vector space or not. For that purpose, I will consider two vectors and try to see whether they follow the properties that we have just discussed or not. So let's suppose we have two vectors. Now let's suppose vector u is over here and this is vector v. This is vector v and this one is vector u. So number one thing, when we add the vectors, they should remain in the vector space. And if you multiply the vector with a constant, any vector with a constant, it should remain in the vector space. But the problem is if we add these two vectors, we will get the answer in the vector space. Let's suppose we add them by using the head to tail rule. So this is u, so I'll put this v on the head of the u. This is v. So this will be my resultant vector. So this is u plus v. So as you can see, this u plus v is in the shaded region. It means that it satisfies this condition. But if we multiply the vector with a constant, then it will go out of the space. How? Our vector v is over here. So if I multiply u with -1, so -1 times u will become equal to -u. That does not belong to the vector space. So -u will be somewhere here. This will be -u. So this vector space, this like vector v is not a vector space. Now let's see another question. All right, so here's the next question. It says, is vector space v xy such that xy is greater than equal to 0 a vector space or not? So first of all, we will shade the relevant region. So over here you can see x and y are being multiplied and we are getting a positive answer. So if we multiply two positive numbers, we will get a positive answer. If we multiply two negative numbers, we will get a positive answer. So the region that is represented by xy greater than equal to 0 will be the first quadrant, because in the first quadrant we always, both the coordinates, x coordinates and the y coordinates are positive. So when they multiply, we'll get a positive answer. And also in the third quadrant, the x and y coordinates are negative. So when we multiply two negatives, we will get a positive answer. So this vector space should lie in the first region, like in the first quadrant and in the third quadrant. Now let's consider any two vectors. So let's suppose we have a vector u that is equal to 1, 2. Let's suppose it belongs to the first quadrant. So 1, 2 will be somewhere here. This is u. And vector v that belongs to the third quadrant, that is -3, -1. So let's suppose vector v is somewhere here. This is vector v. Now we will try to apply the properties. First of all, let's apply the additional property. Like we will add the two vectors and the answer should be from the vector space. So when I'll add the vectors like u plus v, I will get the answer 1 minus 3, that is minus 2, and 2 minus 1, that is 1. So this answer minus 2 1 minus 2 1, it will be from here. This will be u plus v. So u plus v does not belong to the vector space, so we can say that u plus v does not belong to the vector space, hence this is not a vector space. All right, so this is how we can check for the additive properties and the multiplication by a constant, so that the resultant vector should lie within the vector space. In this case, it's not lying in the vector space, so we cannot say that it's a vector space. Okay, now the next thing that we are going to discuss is the vector space for the polynomials. So we'll see some properties of the polynomials, and then we will check whether the polynomials belong to the vector space or not, and how. If they belong to the vector space, then how do they belong to the vector space? All right, so let me just erase it. All right, so the polynomials and vector space. So let's suppose we have a polynomial, for example 3x cubed plus 7x squared plus 3. Now this one, if you have to check the degree of the polynomial, then the degree of the polynomial is the highest exponent that is in the polynomial. So in this one, the highest exponent is 3. So the degree of this polynomial is equal to 3. And if we have to write down a polynomial with 0 degree, then it will be just a constant. So let's suppose if we write 3, so 3 is a 0 polynomial. It's a polynomial with 0 degree, by the way. So polynomial with degree equal to 0. Why? Because if you write x with it, so it's like x to the power of 0, so x to the power of 0 will become equal to 1, so 3 times 1 will be equal to 3. So that's why the degree of such of a constant is considered to be a polynomial, and such polynomial has 0 degree. Now why I'm going to discuss the polynomials with you, because we have to see whether a polynomial belongs to a vector space or not. So for your information, all the polynomials, they belong to the vector space because they fulfill some certain properties. So I'm gonna write it over here. So the polynomials and the vector space, I can write here all the polynomials belong to the vector space. Because as it fulfill the following properties. So let's suppose we have the two polynomials. We have a polynomial p of t that can be written as a0 plus a1 t plus a2 t square plus up till an t to the power of n, and another polynomial that is q of t, which is equal to b0 plus b1 t plus b2 t square plus bn t to the power of n. So we have these two polynomials. So if we add these two polynomials, then we will get a polynomial, of course. And I'll just write it here. So if we add these two polynomials, our answer will be another polynomial that will belong to the category of polynomials. And if we add the two polynomials, like if it's like p of t plus q of t, then we'll get q of t plus p of t. It will satisfy the commutative property. And if we multiply a polynomial with a constant, we'll get a polynomial. So if we multiply a polynomial with a constant c, our answer will be a polynomial in terms of n, and c belong to the real number. Also, if we ask about 3, so 3 is, it's basically a polynomial with 0 degree, so it also is a vector space. So for the polynomials, whatever or whichever polynomial is it, all the polynomials will be will belong to a vector space. So this was some introduction of the vector space and about the properties and how and the conditions by which we can check whether our vectors are within a vector space or not. So I hope you understood it. So that is it for this video. Thanks a lot for watching.